Okay, so in this video we are going to be solving 2003 Calculus AB FRQ question, and it is on accumulation. So it says let f be a function defined on the closed interval from -3 to 4, f of 0 is 3, and the graph of f prime, the derivative of f, consists of one line segment in a semicircle as shown above. On what intervals, if any, is f increasing? So in order for f to be increasing, it has to be above the x-axis. So if you look over here, this part's above the x-axis. So you would say f is increasing for part A from -3 to 2. And the reason it's increasing is because f prime of x, or f prime, is greater than 0. There's not even an x here. Okay, part B. Find the x-coordinate of each point of inflection of the graph of f on the open interval from -3 to 4. Justify your answer. Well, in order for it to be a point of inflection, it has to change from negative to positive or positive to negative. So right here's a point of inflection, and right here's a point of inflection. So you would say at x equals 0 and x equals 2. The reason is f prime changes from less than 0, then f prime changes to greater than 0 at x equals 0. Also, f prime changes from greater than 0, then f prime changes to less than 0 at x equals 2. Okay, part C says, find an equation for the line tangent to the graph of f at the point 0, 3. So we have a point. Now we need a slope. This is the graph of the slope, so m equals -2. It's whatever the value is over here. So now when we do this, we're going to do y minus 3 equals -2 times x minus 0, which is going to give us y equals -2x plus 3. Okay, please give me a second while I clear my canvas because I'm going to need a lot of room for part. So for part D, it says find f of -3 and f of 4. Show the work that leads to your answer. So for part D, we're going to use a fundamental theorem of calculus. So if we have A and we have B, f prime of x equals f of B minus f of A. So when we do this, we want to find from -3 to 0 f prime of x. I got to write it a little bit smaller. Equals f of 0 minus f of -3. We don't have an issue with the f of 0. F of 0 is the 3 given to us right here. So we put the 3 here, minus f of -3. Okay, so now we need to find from 0 to -3. So luckily, we could find this by finding the area over here. So now we're going to have 1/2 1 times 1 minus, what's this, 2 by 2? Yeah, 2 by 2. So 1/2 2 times 2. So now we're going to get 1/2 minus 2 equals 3 minus f of -3. So 1/2 minus 2, what's that, -3/2? 4/2, so -3/2 equals 3 minus f of -3. So now we're going to do a little bit of algebra. We can move this over this way, make it to f of 3 equals 3 plus 3 halves. So now this is 6 halves plus 3 halves equals 9 halves. Okay, please give me a second now while I clear the canvas so I could do the next part of this question. Okay, so now we need to find f of 4. F of 4 is going to be the integral from 0 to 4 f prime of t dt, which is going to equal f of 4 minus f of 0. Well, we know f of 0 is 3, so we have f of 4. Okay, equals, now we need to find the area. So now, if you look over here, I'm going to switch colors. What color will look good? Maybe green. If you look over here, this is basically a square being subtracted by a semicircle. And that's how we're going to find this area over here. If we do rectangle, not a square, rectangle minus a circle will help us. So the area of the rectangle is going to be, what's that, 4 by 2? Yeah, 4 times 2 minus, it's half a circle, so pi r squared, right? Pi. The radius is 2, which is going to equal the same thing, f of 4 minus 3. So now we're going to have 8 minus 4, half of 4 is 2 pi. Okay, so we have the 8 minus 2 pi, but the one thing that I want to point out is it's underneath the x-axis. So if it's underneath the x-axis, it has to be negative. So this part is negative. So we're going to switch all the signs. Negative 8 plus 2 pi equals f of 4 minus 3. So negative 8 plus 3 plus 2 pi equals f of 4. So now you're going to get negative 5 plus 2 pi equals f of 4. Okay, I hope this video helped.